aligned with my very preliminary experiment where just the overexpression of the receptor itself leads to the observed phenomena. So what could be the real reasons for that? We have to look more into the details, and the experiments at present are going, and we also wish to subject further deletion constructs in these studies. So far as the NF kappa B story was concerned, this was our progress so far, but we are looking forward to it further. But apart from this, we were also interested to see that whether knots have any implications in the modulation of the JAK-STAT signaling. And to accomplish this, we did similar overexpression studies in HEC cells where we studied different STAT setups. And here you can clearly see that as far as STAT1 activation is concerned, we don't observe a very clear effect with node 1. But as far as STAT3, STAT5, and STAT6 is concerned, all the three show that with an increasing dose of node 1, there is an inhibition of the STAT activation. But this data got more pronounced when we included the specific inducers of the STATs. And again, we could see that as far as the STAT1 activation with IFN gamma is concerned, we don't observe any clear effect here. But the most pronounced effect that was observed over here was the STAT3 activation by IL-6. Though we also see a nice effect with STAT5 and also an inhibitory effect with STAT6, but for us, the most pronounced effect for the time being is STAT3 activation with IL-6. So we decided to go into more details into this particular experimental setup, and again, we subjected the activation of STAT3 with IL-6 using different deletion constructs. Here again, you can observe that the wild type node 1 with an increasing dose leads to an inhibition of the STAT3 activation. This, surprisingly, to somehow is still retained both in delta CAR and delta LLR. Like here, either the LLR domain is deleted, the CAR domain is deleted, but we are not that sure of why the effect is still retained here. So maybe to validate this particular observed phenomena, we need to look using further deletion constructs or constructs having specific domains only, because I want to stress that here, though one domain is deleted, but say the not domain is present, so we are not sure of this particular hypothesis, but we have to work further to become more sure of this phenomenon. But just to believe that the phenomenon that we are observing is an effect and not an artifact, we included a controlled experiment over here where we used the overexpression of SOX1 mutant, and to our delight, we could find that there is almost a complete abolishment of the nice inhibitory effect that we observed in the case of NOD1 wild type. And this was quite boosting for us, and we could easily believe that the observation we are having is in fact an effect rather than any artifact. So this was really quite exciting for us, and we are looking forward to do further experiments in this setup. So far, we were glad that we successfully validated our experimental setup, our methods at the beginning. We could observe that NOD1 overexpression has a clear effect on the activation addition of NF-kappa B and STATs, but in completely contrasting manner. As far as the NF-kappa B activation is concerned, not overexpression leads to an enhancement, whereas as far as the activation of STATs is concerned, it leads to an inhibition. And of this inhibitory effect, this is retained both on the constitutive as well as the inducer specific activation of the STATs. And in this STAT setup for us, the most exciting so far has been the activation of STAT3 by IL-6. So further, we would like to elucidate and find which domains are really responsible for the observed effects that we have so far. We would also like to find that what could be the possible interacting partners of NOD1. We would also like to go more into detail of the NF-kappa B experimental setup, and in fact I want to mention the experiments are going on now. I expect some results by this weekend, and that what would be the inducer's specific activation being affected by overexpression of NOD1. And finally, we would like to extend our studies to dendritic cell to add more valor and biological significance to our data, and finally arrive at a point where we could really learn and understand and help others understand that what are the wider implications of NOD1 in the modulation of the immune system. So finally, I'd like to thank the members of my group who have helped me a lot to learn and perform here in the lab. I also want to extend my regards to the members of the Thalama group for the constant guidance and support. I like to thank my friends for standing by me in hard times. I express my deepest regards to Professor Schwarzenberger, and I seek his blessings further for the progress of my thinking. And finally, I extend my deepest regards to Professor Seth Thalama, my supervisor Jutta, and above all my mentor Albert Duschel, to provide me this wonderful opportunity of my lifetime to become a better scientist. Thanks you all for your attention.
Thank you very much, Sami. Considering dark times, you can imagine what life is like when you're studying a receptor and the effects you have are retained when you delete the receptor domain. That is a little bit shaky eyes you are on at that moment. So questions?